Well, good afternoon. Good afternoon. Kind of a slow group today. And once again, I find myself between y'all and lunch. So it's a very bad position to be in. I want to thank you for having me here this weekend. It's hard to believe it's over almost. And I've had a delightful time. I hope you'll see fit to bring me back again. I'd love to come back to Norway. Perhaps get a little farther north and take in more of the country. And I'm certainly looking forward to seeing many of you in Kentucky at the Ark and the museum. I found a few of you have been there, but I've told them that it's been so long, we've made so many changes that it's not the same place. You need to keep coming back. And if you're going to come that far, you might as well spend a little more time. I suggested the possibility in April of 2 years from now when there's a total solar eclipse. We haven't really arranged what we're going to do yet, but I'll be doing something that day. And then there are other things to do in the area. If you really ask me nicely, I could take you on a hike all day to my favorite place in the world. It's just a 2-hour drive from the Creation Museum. So I love going down there and I love sharing it with people. It's a beautiful place and I think Norwegians would probably enjoy it quite a bit. Anyway, I'm going to wrap up today with biblical cosmology, or if you will, the alternate title is the Canopy Model Round 2. As it started out yesterday, and some of the protagonists don't seem to be here, so that's maybe they'll show up yet. At any rate, what is cosmology? Well, cosmology is, if you look at it, comes from the two Greek words, cosmos meaning world, and logos meaning literally word, but generally the study of. And if you look up a dictionary definition, cosmology is a study of the structure of the universe. There are many different types of cosmology. The idea that the Earth is orbiting around the sun, we call that the heliocentric cosmology. That's an example of a cosmology. If the Earth is sitting at the center of the universe and things are going around it, then that's also a geocentric cosmology. But today we generally reserve the word cosmology to talk about not just a subset of the universe, but actually the entire universe as a whole. And one thing I've struggled with as an astronomer over the years, as a creationist, is what kind of cosmology does the Bible teach? And I must say my ideas were not well formulated for many, many years. My first book was written over 20 years ago, Universe by Design. I think they have a few copies on sale still. And I still believe much of what's in that book, but some of my ideas have changed. And in the last decade, I'll be sharing with you this morning my ideas about changes there. Now, if I'm going to approach this as an astronomer, I want to ask, well, where is astronomy and where is cosmology mentioned in the creation account of Genesis 1? And I can see three possible places. One is in the very first verse. In verse 1, it says, "In the beginning, God created the heavens and the earth." So you've got a mention of the heavens there in some respect. And then you go right to day 2, and in verses 6 through 8, it says that God made this rakia. I'm putting in there the Hebrew word, rakia, because, well, as you're going to see, it's a big bone of contention. How do we properly translate and then understand this Hebrew word rakia of this thing God made on day 2? And finally, on day 4, on verses 14 to 19 of Genesis 1, God describes how he made the heavenly bodies, the luminaries, the sun, the moon, the stars, basically everything astronomical, everything outside of the earth. Now, over the years, there have been many attempts to wed the Bible to current cosmology of the day. That is, men think about the world a certain way, they develop a cosmology, and then they try to interpret or understand Scripture in terms of that. Do you see that that's a problem? There's a danger there. We should not be interpreting Scripture in terms of man's ideas at all. Instead, we should be interpreting man's ideas in terms of Scripture. It's so easy to get it backwards, and I am well aware of that problem, and I'm well aware that sometimes I may slip into that. But, if I'm guarded on that, if I know that that's a potential pitfall, then I can be prepared to account for that and hopefully avoid that problem. And I will give you 3 examples from history. One is what we call the celestial sphere. This is one way that people have understood Scripture, even actually translated Scripture to reflect this, as we're going to see. Then we have what's called the Ptolemaic Model. This is a model invented by Claudius Ptolemy in the 2nd century A.D., and it was the most successful theory of science, I think, ever. It lasted 15 centuries. So in terms of longevity, it was a particularly successful theory. Nobody really believes it today, but it was widely believed until about 400 years ago. And then today we have what's called the Big Bang, which is oftentimes called a cosmology. Technically, it's not a cosmology, it's a cosmogony, which is a theory of the history and the origin of the universe. But I'm not going to try to separate the two, cosmogony and cosmology. They're kind of blended together anyway. Well, what about the ancient Greek cosmology? Well, if you go out and you look up in the sky, at night particularly, what does the sky look like? What kind of shape does it seem to have? It looks curved, looks like kind of like a dome, doesn't it? Sitting over, at least like there's a hemisphere sitting there. That's why planetaria works so well. You go with the dome ceiling, they can project the stars up to fool you on this. Now, why do our eyes do that? When we look at objects more than a few feet away from us, we lose that three-dimensional look. We have stereoscopic vision that helps us judge distance, but once you get very far, you lose that. And so when you look at distant objects, you tend to map them in 2 dimensions. You tend to map them or visualize them very flat. I look off in the distance, and I see objects, and they look very flat over here. If I look over here, they look very flat. If I look over here, they look very flat. And if I start mapping all around like this, locally it's flat. But if I keep doing this, you can see my hand going up like this, everything I see in the sky, what kind of shape am I then mapping it onto? A dome. It's an illusion. Things are at various distances, but we imagine that we have a dome sitting over top of us. That's what it looks like to us because we lack that three-dimensional view. And so if we don't see that third dimension, everything looks two-dimensional, and that maps then onto a hemisphere. It doesn't go onto a sphere because there is well, the Earth gets in the way, horizon we call it, and blocks the view. But if you watch things in the sky, like the sun and the stars, they rise, they move across the sky, and they set, and then they come around and rise again. So it's pretty easy to convince yourself that what surrounds us is not a hemisphere, but really a sphere, of which only half you see at a time. Does that make sense to everybody? So they constructed a model that looked like this. I took this photograph in the lab where I used to teach. We had, in the astronomy and physics lab, we had 7 of these globes. And my students, I would bring them in. We'd do a couple of labs in an astronomy lab where we would set these globes up and look for certain relationships. It's very great for showing sunrise and sunset, midnight sun, also no sun above the horizon for 24 hours above the Arctic Circle. All sorts of cool things you can illustrate because it's three-dimensional and you can put it together. And the illusion is you think all the stars are the same distance away from us. Now, if you look very carefully at that celestial sphere, well, you see in the middle there's a globe of the Earth. You can see South America showing up there. And then you have this other globe sitting around it. It's got little yellow dots on it. See the yellow dots? Those are stars. And they map on that celestial sphere. Now, up above near the top, the little left of top, there's a little yellow ball on a shaft. You see that? That represents the sun, and I can move it around independently of the stars. And then about halfway down, it doesn't show up really well, there's a horizontal disk that goes around the Earth. That represents the horizon. So when I rectify this globe for a certain time and location and date, then everything above that horizon's visible, and everything below is not. It works pretty well to describe what we see. And by the way, since I'm at the Answers in Genesis now, we purchased a dozen of these globes. These are smaller ones we purchased. They're not as good as these old-fashioned ones from 50 years ago, but we use them in workshops there at the Creation Museum. And I love doing this little workshop because a lot of adults are in there, and I start having them set up stuff, and they start seeing the sunrise and sunset and seasonal changes, and little lights go on in their eyes. It's amazing. You know, people who never really learned the true cause of the seasons growing up, and now they're nearly as old as I am. For the first time, they understand what causes the seasons. Hint: it has nothing to do with the changing distance of the sun. Most of us were taught that growing up. I was. And that's not it, actually. You can ask me later if you really want to know. I don't have time for that right now. Now, the Greeks had a word for this thing. They thought that the stars were all about the same distance on this globe sitting around us. And I think Aristotle concluded it was at least, not Aristotle, Ptolemy concluded that the radius of that celestial sphere was at least 10 or 20,000 times out of the Earth. So obviously this globe is out of scale. The Earth globe inside's too big or the dome's too small, but it's just a compromise to make it work. And they had a word for this thing to describe it. The word is stereoma, and that's a Greek word which refers to something hard, something firm. In the New Testament, when the Apostle Paul wrote to stand firm in the gospel, he used this word. So this is not a bad word to describe this thing that the Greeks thought surrounded our planet, because it does a good job of describing things. Does anybody believe this model today? No, nobody does, as far as I know. Does that mean it's worthless? Well, no, it's a useful tool. You know what? In physics and astronomy, we often use models that are not really correct, but we use them anyway because they're useful. How many of you learned the Bohr model in school? Yeah, the little electrons going around. Is it a true model? Not really. It's a good approximation, but that's, if you really understand some quantum mechanics, it's not exactly what's going on, but it's close enough. Tell me, Andy, do you, Andy, in your thermodynamics, do you treat heat as a fluid? No. In your thermodynamics, you don't heat as a fluid? No, but people have done in the past. I treat it as a fluid. If you have heat flowing from one thing to another, it's a fluid, isn't it? But is heat a fluid? And the answer is no. The point is, we physicists, we do treat it as a fluid. It's a theory that's been discredited, but we still use it. Why? Well, because we find it useful. We do that a lot in physics, believe it or not. So we have true theories, we have untrue theories. Let's don't go there, folks, okay? We are trying to find the truth, I think, but sometimes it's very elusive, isn't it? Okay, so the celestial sphere is this important concept out there. Well, you know, in day 2 of the creation account, God made this thing that's called the Rakia. So what is it? That's the big question I've had for years, and now I think I know the answer to that. But, you know, around 2nd or 3rd century BC, you had a group of Greek scholars that, Hebrew scholars, excuse me, that collected in Alexandria, Egypt. They translated the Hebrew Old Testament into Greek at the time. Why did they do that? Well, because of the diaspora, so many Jews didn't speak Hebrew anymore, couldn't read Hebrew anymore, and it's very important that they read the Scripture. So they're doing a great labor of love here to put what was then the Bible, the Old Testament, into the common languages, or common language at that point. The universal language was Greek. And we call this translation, anybody know? It's called the Septuagint. And it's illustrated, it's indicated by Roman numerals for 70, LXX. So when the translators of the Septuagint got to Rakia, they translated as stereoma. Why? Well, to be honest with you, we don't know exactly why. But my belief is they were in Alexandria, major city of Greek learning and culture. The great library was there. These were not uneducated men. They were very well educated. And they certainly knew of Greek thought at that time. And at that time, the Greeks believed the earth was surrounded by this stereoma, this celestial sphere. I believe very firmly what they were doing there was they were translating Scripture into Greek to reflect the cosmology of the day. Very dangerous thing to do. They weren't asking, what does this word mean? They're asking, what do we think this word means? They were reading in man's ideas, and you know, here we are 23 centuries later, and we're still paying the price with this. How so? Well, a few centuries later, what, about in the 4th, 5th century, at least in the western part of the Roman Empire, the Greek was falling out of disfavor in favor of Latin, and so they needed again to put the Bible into the common language once again. I think it's something new, isn't it? No, we've been doing this all along. Except now it wasn't just the Old Testament, it was also the New Testament. The common language then was Latin, so a guy named Jerome translated, and he called that the what? Anybody know? The Vulgate. So when Jerome gets to the Vulgate, he gets to this, and he looks at this, and instead of going back to the Hebrew and saying, what does the Hebrew rakia really mean? He took that Greek word stereoma and found the best Latin word for it, and the word is firmamentum. if you wanted to, well, I don't know what the word is in Norwegian, but if in English you want to know what it means, just look at the first 4 letters. F-I-R-M. Firm. It turns out firmamentum is a very good Latin translation of the word stereoma. But it's a terrible translation of the word rakia. And of course, you go another 1,000 years into the beyond that, and now Latin has fallen out of use. And in the British Isles, you get a guy named Tyndall who wants to put the English, the Bible in the common, 700 years ago. Common language now is early Middle English, and he's trying to put it into the common language. And so he gets to this word, and Tyndall didn't know Hebrew. All he knew was he knew Latin, and so he's translating the Latin Vulgate into English. And he gets to this word firmamentum, and he's thinking, how do I translate that into English? He didn't know. So what he did is he coined a new language, new word. He transliterated firmamentum into English, and that transliteration becomes firmament. And that is how the word firmament was introduced into the English language. And for the next 3 or 4 centuries, that is how people translated that word. Even when they had the Hebrew text now, they continued to translate it firmament rather than translating it what it ought to be. Now, eventually in the late 19th century, people, and now, and even today, people are trying to claim that this word means a vaulted ceiling, a domed type ceiling. We're back to this illusion I mentioned, except it's not an illusion. It's a real, tangible, physical dome sitting over the earth. That's how we've gone full circle in this. Michael Heiser, I mentioned him the other night. He's one of the ones really pushing this idea today, that this is what the cosmology of the Bible is. And so there are many people putting this forth as what Genesis and the rest of the Bible teaches us cosmology, and I entirely reject that. I don't think history really supports that. I don't think Hebrew really supports that, and certainly the reality of the world around us doesn't seem to support that. It's setting the Bible up for failure, that the Bible's wrong, so therefore how can you trust the rest of the Bible? Michael Heiser would strongly object to my saying that this morning if he were here, but he's a man who says this is what the Bible teaches, yet he's also a man that doesn't believe that that's what the real cosmology is. He's also a man who claims to believe in the authority and inspiration of Scripture. If that doesn't make any sense to you, congratulations, it shouldn't. Michael Heiser is a very confused man. All right, it's gotten so bad that you have this engraving coming along many times. You see there a flat earth, you see a dome, and you see some intrepid explorer who's found his way to the edge of this firmament, and he's peeking through on what's going on behind. Anybody ever seen this woodcut before? And it's usually depicted as being medieval. It's supposedly reflecting medieval thinking back when everybody thought the earth was flat and all that kind of stuff, which I dealt with Friday night, which is nonsense. It's a big fat lie. Well, I guess it is considered to be medieval. Flammarion was a guy who wrote a book that had this on the cover. That is, if you believe it's medieval, if you believe that 1888 was in the Middle Ages, because that's when this appeared. And people can't get the story straight, can they? So I would submit to you the translation of rakia as firmament is a very bad translation, and I've been living, when I first got into astronomy and I decided to be a creationist, it was going to be my calling in life to be an astronomer for God's glory. That was over a half century ago, and I thought, well, I better read Genesis and make sense of it. I started reading, and I got to this firmament thing, and I had no idea what that was, and my father couldn't help me, and none of the meager resources we had. This is long before the internet. Yes, kids, the internet has not always been there. Believe it or not. Shock, 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 you know. Yeah, we only had 3 TV stations when I was growing up. You know that?
Well, you were living in South Carolina.
No, I was living in Ohio at the time. Yeah. How many stations do we have now? I have no idea. I can't count them. I can't count that high. I live in Kentucky. I have to take my shoes off, you know, to count that high. Well, round 2 on this, the Ptolemaic Model. I don't have time to talk about this, but the stars remain in the same relative position all the time. They move throughout the sky because of Earth's rotation every night. They change seasonally, but they come back next season. They're pretty reliable. That's why I can use those celestial globes year in and year out, because the stars really don't change much throughout human history. However, there are 7 objects in the sky that do move. One is the sun. It moves across the sky daily, but with respect to the stars, it moves through the stars once a year due to our revolution around the sun. The moon also moves once a month through the stars. And then you got 5 bright objects. They look like stars. They're called planets, which means wandering stars, is where it comes from. These are Mercury, Venus, Mars, Jupiter, and Saturn. As it turns out this spring, we've been treated to 4 of them. The 4 brighter ones, Venus, Jupiter, Mars, and Saturn, have all been in the morning sky. Have any of you seen any of those planets? They're really cool to watch. They've been going through quite a dance. Well, this month, a little later on, Mercury is going to join them. Lots of luck seeing that this far north. Okay, Mercury's kind of hard to see. Somebody just overnight asked me, emailed me, and said, what about this story? What do you think about this? And so I answered, well, it's kind of rare, but not that big significance. And by the way, you probably won't see Mercury. But they look like bright stars, but they move through the stars. It takes Mars about 26 months to move through the stars. It takes Jupiter about 12 years. It takes Saturn about 30 years. Once every 20 years, Jupiter and Saturn get together. That's what we call a conjunction. I saw one in 1980. I saw one in 2000. I saw one in 2020. I hope to see the one in 2040. All right, they get together infrequently like that. Now, their motion is usually west to east through the stars. However, from time to time, they slow down and they start moving east to west through the stars, what we call retrograde motion, and then they go back the other direction. Now, what's going on there is we're passing up those planets in our orbit. We're moving faster than them and leaving them behind. It's like driving down a highway. In the United States, we'd say you're passing a car. In the UK, you'd say you're overtaking the car. What do you say here in Norway? Which means passing through the car? Passing around the car. Okay, it's a little longer statement than we have in either the UK or here. But you get the idea. And when you do that, what does that other car appear to do? It appears to move backwards, doesn't it? It's moving backwards with respect to, eventually it starts moving forward again. It's an illusion caused by our passing them up. And the planets do the same thing. But you see in the Ptolemaic Model, the Earth was the center of the universe, and everything went around it. So how do you explain retrograde motion? Well, I've been running this little thing in the background. What he did is he had the Earth in the middle. Then you got Mars, that little red dot. Instead of Mars going directly around the Earth, Mars goes on a little tiny circle we call an epicycle. And then the epicycle in turn moves forward, the center of which is that little white dot. It moves around the Earth on a much larger circle called a deferent. And if you combine those two motions, you can see that the apparent motion goes forward. Let's see there it goes forward, then it goes backward, and then it goes forward again. Everybody see how that's working? All you have to do is adjust the sizes of the two circles and the two speeds, the relative speeds of those two motions, and you can get a pretty good fix. This was a brilliant model. In the past, people had noticed the motions of the planets. They couldn't model them very well at all. Hence, they couldn't predict them very well. And people believed in astrology. You had to know where things were in the future and in the past, and you couldn't do that without a good model. Ptolemy gave them that model. And no wonder this model was so successful for 15 centuries. So, it's a geocentric model. And it was widely accepted in the ancient by the 2nd century. And then the Roman Catholic Church comes along, particularly about 1,000 years later, and it's adopted in a formal sort of way. It is endorsed by the Roman Catholic Church, largely through the influence of Thomas Aquinas. You heard of him, right? Early on, you had around, the 5th century, you had Augustine who wrote, and a lot of people really liked him and put his ideas forward. Augustine really liked Plato quite a bit, and a lot of his ideas he borrowed from Plato. So Plato was very common in the first half of the Middle Ages. But then in the 11th, 12th century, suddenly Aristotle becomes back into vogue. Thomas Aquinas takes Aristotle and what Augustine had done for Plato, Aquinas does for Aristotle and for Ptolemy, and it's a real paradigm shift that occurred there in the Middle Ages. And this then set up a few centuries later the so-called Galileo Affair. You've heard of that, right? And the usual interpretation people give is that Galileo was moving forward with science, and that the church said, oh, no, you're wrong, like it contradicts the Bible. It's all is a religion versus science thing. Have you all heard that sort of approach? Again, they lied to you. It's utter nonsense. It was not a conflict between religion and science. It was a conflict between science and science. Turns out, the long story, I could go have a whole talk on that, but I don't have time. Galileo, when he put forth his ideas, he was immediately pounced upon by the theologians, right? Wrong. The Pope was impressed with what he did, and other people kind of liked it, no problem. You know who complained? The other scientists complained. They didn't like it at all because he was upsetting their established theory. So what usually happens is they say, well, Galileo Affair, you're doing it all over again with creation, evolution stuff, and you people are like the Roman Catholic Church and the evolutionists are like Galileo. And I'm saying, wait a minute. Galileo was challenging the status quo, and the other scientists reacted to that and resisted it. So if you really want to make that comparison, who's Galileo? We creationists are. And who's the Roman Catholic Church? The evolutionists are. Get it straight. The only thing worse than not learning lessons of history is learning the wrong lessons of history. But I digress. That's not my point today. The thing is, this never would have happened if the Roman Catholic Church had never wedded itself to the Ptolemaic Model. So first of all, you got messed up with the embrace of the celestial sphere, that stereoma thing. Number 2, the Ptolemaic Model. Then number 3, we made the same mistake in the 20th, now the 21st century. The Big Bang became the dominant cosmology or cosmogony in the past half century, really after about 1965. Believe it or not. Before that, it was not widely believed. By 1970, it was. And what is the Big Bang? Well, I would tell you in very short one sentence, it's the belief that the universe suddenly appeared 13.8 billion years ago. When I say the universe has suddenly appeared, I'm not talking about just matter and energy. I'm talking about space and time. Space and time came into existence. Sometimes people ask what was here before the Big Bang. As I used to tell my students, that question makes no sense because here denotes space and before denotes time. So simply I could tell you that according to the Big Bang model, here wasn't here then, and then wasn't then either. Yeah, parse that out. Okay. And the universe came into existence in a very hot, dense state, expanding. It's been expanding for 13.8 billion years, and as it did, it cooled, and this is the universe we see today. That, in a nutshell, is the Big Bang model. And I would say that there are many biblical and scientific problems with it. And I've given talks about this in the past. Now, what really changed everything? The model was first proposed in its nascent form around 1930, in its more correct modern form around 1948, but it didn't really gain any traction until around 1965. A couple of men named Arno Penzias and Robert Wilson, they were astronomers working for Bell Labs, and they stumbled across an accidental discovery. They had a special antenna that they pointed everywhere in the sky, and when they did, they picked up a faint signal coming from everywhere at a very low temperature. And this is a map of what it looks like, a fairly modern map. We've improved upon it over the years. I will try to explain to you what this map is showing you. Have you ever seen a map of the Earth that looked like this? The north and south poles at the top and the south poles at the bottom, and the equator runs down the middle. And there's kind of a distortion built into this thing. Everybody understand what I'm saying? So you can imagine that the United States is right there in the middle, right of center where it's supposed to be, or above center. South America below that, and Russia's split in two on either side, you know. Yeah, I'm still back in the Cold War, I know. And so Norway would be over to the right a little bit, okay, up near the top, and probably a little bigger than it really is, but that's okay. You don't mind, do you? All right. So you get the idea what I'm talking about. Well, remember, you're looking down on the globe of the Earth, right? What happens if you look up and see that celestial sphere we map out? Same thing. We're just looking on the inside rather than the outside. So this is the map of the entire sky that's been measured by this. And this background radiation, they call it the cosmic microwave background, or CMB for short. It's in the microwave part of the spectrum, and it has a temperature of around 2.73 Kelvin. Now in real temperatures like minus 270 degrees Celsius, or in really real temperatures like minus 450 degrees Fahrenheit, it's really cold. But those little yellow and white areas you see, those are warmer than average areas. And then there are little blue areas on there. Those are cooler areas, and they differ in temperature by about 1 part in 10,000, like 0.0003 Kelvin. Yeah, we can measure that. Isn't that amazing? By the way, before I move on, I want to show you something important across here. You see this big, long ridge right here? It's warmer than average right there. Y'all see what I'm talking about? It's a warmer than average region of the sky that actually coincides with the Earth's orbit around the sun. Coincidentally, quote unquote. Nobody knows what it is. The Big Bang model can't explain it. They call it the axis of evil. They do. And down here is what they call the great cold spot. It's a cooler than our area, and they don't know what causes it either. Two big problems that they have. Now, this was predicted. The existence of such a background radiation was predicted back in 1948, but the technology did not exist to find it yet. 15 years later, it did, and that's why they found it in the mid-60s, that the technology was there. And the guys that discovered it a dozen years later got the Nobel Prize in Physics for the discovery, because it was a prediction. Its existence was predicted by the Big Bang, and this is taken as evidence of the Big Bang. So I've been giving talks for years about the Big Bang and how it isn't biblical and has some scientific problems. And in one of my early talks, and it's happened since then too, a guy would come up to me and say, or in the Q&A, and say, well, if the CMB did not come from the Big Bang, then what is it? Where did it come from? And my answer was, I don't know, which is an honest answer. It's a good question, which I wish I had an answer to. Would you agree? Yeah. Well, I think I have an answer now. I'm going to share it with you. That concludes my introduction of my talk, all right? All right. Scientific problems with the Big Bang. You got the horizon problem, flatness problem, the no magnetic monopoles, asymmetry between matter and antimatter, axis of evil, great cold spot, and the model continually changes. I don't have time to talk about any of those. Ask me later if you're curious. All right. Biblical problems, I'll do a quick rundown. First of all, it's a great time. I understand the world's only thousands of years old, not billions of years old. Another problem is the order is wrong. You have light before the earth. You have stars before the earth. You realize that the earth is a Johnny-come-lately, that there have been stars going on in the earth and the universe for 9 billion years before the earth and the sun and the rest of the solar system came about. That's what modern cosmology tells us. That directly contradicts what Scripture says. It's also atheistic in the origins and where it goes with things. Okay, let's go down to what's important. That's what the world wants to say, my introduction, as I said, but I want to know, I don't care what man's ideas are, really. I want to know, what has God revealed to us about cosmology? What kind of cosmology is in the Bible? Well, the very first verse says, in the beginning, God created the heavens and the earth. Now, that seems like a pretty straightforward statement. Or is it? I'll come back to that in a minute. All right, let's look at day 2. God made this thing. I prefer to call it the expanse, or actually I prefer to use the Hebrew word rakia. If we can't really translate it properly, why not just leave it in the Hebrew, kind of transliterate it and worry about it later. Firmament, expanse, rakia, whatever, just don't call it a dome. He made that on day 2. So day 1, day 2 sort of taken care of here. Okay, firmament is mentioned, heaven is mentioned. What about these two words? Let's look at the first one, firmament or expanse. As I said, the Hebrew word is rakia. Okay, great. Let's find out what that word means. Let's look and find out how many times it occurs in the Old Testament. Well, it occurs 17 times. Okay, I don't know what it means in chapter 1 of Genesis, so let's go look at what it means in all those other places in the Old Testament. Great, we got a problem, because 9 of the times occur actually in Genesis 1, which means I got 8 verses left outside of Genesis 1. You see the problem? The word I'm trying to figure out occurs the majority of the time in the chapter I'm trying to figure it out. That's no help at all. Furthermore, it's found, I believe, 5 times in the book of Ezekiel, and I am thoroughly convinced that it's not talking about the firmament or the rakia at all. So now I'm down to what? 3 other verses? Not very many to work with. That is a real problem. What about heaven? Well, that's a lot easier. The word is shemayim. It occurs 420 times in the Old Testament. Usually it's translated heaven or heavens. I think 398 times. I'm talking about the King James now. The other 22 times it's air or sky, usually. Why is it translated heaven or heavens? Why is there confusion there? Anybody know? Look at the Hebrew word shemayim. If you know anything about Hebrew, you can tell me something about that word. It's a plural. That's how you make a plural usually in Hebrew. You put an "im" ending on the end of it, like cherubim and seraphim. You ever heard anybody say cherubims and seraphims? I've heard people say that. They think, you got seraphs and you got cherubs and you got cherubims. No, a cherubim is a plural. So you got a cherub and you got two or more cherubim. You don't have cherubims. I don't know why they just don't know, I guess. I probably didn't know myself at one time. The problem is there's no singular form of this. And so when you want to translate it into English, you need to know, is it plural or is it singular? Now, if it's the subject of the verb, of the sentence, then the verb will tell you if it's plural or singular which one to do it. The problem is, I think 418 times it's the object in a sentence. It's only once or twice is it the subject. One place I know is in Psalm 19, and it's plural verb is used there, and so every translation says the heavens declare the glory of God. But in Genesis 1:1, many translations say, in the beginning God created the heavens and the earth, and other translations say, in the beginning God created the heaven and the earth. And people scratch their heads and wonder, oh, why is there a difference? Well, it's because the translators thought of it differently. Is it plural? Is it singular? It's just tricky to do that. Now, let's go back to the word rakia. What does it mean? Well, it comes from a verb meaning rakah. The word is rakah. And that happens a lot in Hebrew. We take a word and they will take a verb and they will make a noun out of it. And the word rakah means to stamp out. It's sometimes used to stamping of a foot. Later on in the Old Testament, it's talking about trampling down the streets of a city when you've conquered it, and that's a rakah, doing that. You're rakahing when you do that sort of thing. But it's also used referring to beating out a metal such as gold. Silversmiths are mentioned there about using rakah to do it when they were taking some bronze material that was being repurposed in the wilderness to make the tabernacle, part of the furnishings of the tabernacle. They rakah'd the bronze, beating it, spreading it out like this for repurpose for that for the tabernacle. Now, many times people say, aha, since a metal is often the object of this action, then it must have some property of a metal, such as hardness. And I'm saying, well, wait a minute, why can't it be luster? Why can't it be electrical or thermal conductivity? Why does it have to be hardness? Furthermore, if you're going to try to figure out what a noun derived from a verb is, you generally are going to use some aspect or property of that action, not some property of the subject or the object, I should say, of the action. And I give an example there, the word expand. We get that word from the French, and if you expand something, then it becomes an expanse. And this is interesting how that works, because that's exactly what's going on here. If you look in most of the lexicons, all the lexicons really, it will tell you that the word means expanse. Martin Luther, in his commentary on Genesis 5 centuries ago, wrote about the Septuagint. He said, I don't know why they translated it stereoma, because it means expanse. Yet he himself, when he translated Genesis, he didn't say expanse. He used a German word which translates to English as stronghold. I have no idea why he did that. But it's been known for a very long time. It's not a modern idea at all. It's been known for a very long time that rakia means expanse. Something that has been expanded or stretched out like this. So let's look at Genesis 1, 6 through 8. And I've got this from the ESV, I believe. It says in verse 6, and God said, let there be an expanse in the midst of the waters, and let it separate the waters from the waters. And God made the expanse, and separated the waters that were under the expanse from the waters that were above the expanse. And it was so. And God called the expanse heaven, and there was evening, and there was morning the second day. when you're trying to figure out what this expanse is, it gets really tricky on just, if you can figure out where the waters are above or what the waters are above, that could help you figure out what the expanse is. But that's tricky too, so maybe if you figure out what the expanse is, it'll help you figure out what and where the waters are above. Well, see, it's a problem, chicken and egg problem. You got to kind of do a whole package deal here to figure this out. Well, let me do a little summation here of what we've seen so far. I've talked about day 1 and day 2 so far, 2 separate events. And you got waters separated above. Again, what are they? Where are they? Are they still there? What's in between? I don't know yet, as far as my presentation is concerned. But we do know this, that God didn't make the stars until day 4. So I have a hard time illustrating something about day 2 because, well, I just illustrated it with a picture of the Pleiades star cluster, which is stars, so I apologize, but I didn't want to just put up a blank slide up there. Okay, it's a pretty picture. Just ignore what you see in the picture, though, all right? Now, what did God make on day 1? Verse 1, God, in the beginning, God created the heavens and the earth. And on day 2, he makes this thing, this rakia, and it says in verse 8, and God called the rakia heaven. Did you catch that? He called it, in the beginning, God created Shemayim and Eretz, heaven and earth. And in verse 6 and 7, he makes this thing called an expanse, separating waters. And in verse 8, it says he called this rakia, or expanse, Shemayim. He made something on day 2 that he's calling Shemayim, but he created Shemayim on day 1. So did God create the heavens twice? Did he make it twice? It says pretty clear he made something on day verse 1 that he is heaven, and said he made something in verses 6 and 7 that he in verse 8 called heaven. So did he make it twice, whatever this thing is? And are they the same thing? Yeah, it's food for thought, isn't it? Let's move on to day 4 to get another clue here. And I'm just going to give you pieces of 3 verses from the day 4 account. Verse 14, it says, the command God gives, let there be lights in the expanse of heaven, the rakia of Shemayim, to mix English and Hebrew. And in verse 15 he says, and let there be lights in the expanse of the heaven, the rakia of Shemayim. And in verse 17, and God set them in the rakia of Shemayim. You notice 3 times God uses this construct, rakia of Shemayim. Why do you think something is repeated 3 times in Scripture in close succession? Why do you think that's the case? It's for emphasis. This is important, is what it's saying. You ever had a teacher tell you, this is important, it's going to be on the test. It's very important, it's going to be on the test. Now, we'll tell it to you several times. Why? Because just in case you're not listening, pay attention, or you're dumb as a sack of rocks, you need to get that idea across, right? And sometimes we're all dumb as sacks of rocks, aren't we? I think God said this 3 times for a reason. I think it's for emphasis. And also, it's not just that I put them in the heavens. I didn't say I just put them in the expanse. He says I put them in the expanse of heaven, that rakia of Shemayim, tying together those 2 words that are used first in verse 1, but then expanse or rakia in verses 6, 7, and 8, and then heavens at the end tied to it. I think that repetition is telling you, lest there be any doubt or misunderstanding, God placed the heavenly bodies in the thing he made on day 2. Say that again because it's important. I think it's very clearly indicating that when you compare the day 2 account and the day 4 account, whatever this thing is God made on day 2, God filled it with the heavenly luminaries on day 4. That puts a different spin on it now, doesn't it? Now that construction, Shemayim of heaven, rakia of Shemayim, expanse of heaven, occurs one more time. It's in verse 20, at the beginning of the day 5 account, and it says, and God said, let there be waters, let the waters swarm with swarms of living creatures, and let the birds fly above the earth across the expanse of heaven. Expanse of heaven is used again, but this time there's another term thrown in there, and the translation here I don't think is maybe the best, but it's talking about, the word is pane that's used, which means face. Remember in verse 2 when it says the Spirit of God was moving on the face of the waters? Same word, pane. I think most of us are thinking on day 2, God's brooding or hovering over the surface of the water. So if the birds are flying on the face of the rakia of Shemayim, it's got to be the surface or near side of it, right? Just like you are in verse 2 with the waters. So whatever it is, the birds are either right in front of it or right at the edge of it, of this thing. Psalm 19:1, the heavens declare the glory of God. That's the Shemayim declare the glory of God, and the rakia above proclaims his handiwork. That's where rakia occurs the next time in the Bible. Now, Psalm 19 is like any psalm. It works, there's a parallel structure. And notice the parallelism there. You say something twice, you say it one way, and you say it another way. And what it's telling us here is that the Shemayim and the rakia are the same thing, at least in the context of what it's talking about here. But hey, we already knew that from verse 8 of chapter 1 of Genesis. He said, I'm going to call this rakia I just made, I'm going to call it Shemayim. But you go reading on, if you read the rest of the first 6 verses of Psalm 19, it very clearly places the sun in the thing that he's talking about, this rakia and Shemayim. So it ties it together very nicely with chapter day 4 account as well, that whatever he made on day 2, that's where he put the heavenly bodies. So here's my conclusion, not of my talk, but what I think the expanse is. I believe the expanse is where the astronomical bodies are. Now, at the risk of reading into that my modern cosmology and your modern cosmology, let's just put it in 21st century parlance. What would you call that today? Space. That's right. Outer space, we used to say, no, we just say space. So I'm coming to the conclusion now that basically when God created the earth at the very beginning, it wasn't done by a long shot. It was a watery mass of some sort. But he didn't even create the space of the universe until the second day. You realize that for one whole day, all that existed was the earth and light on it? Can I imagine that? Can I put it together? Absolutely, I can't. But that's all that existed for a day. Wow. Now, as I alluded to a question yesterday, I think people have misunderstood this for a long time, myself included, many years. For much of the 20th century, many creationists embraced what we call the gap theory. I mean, not the gap theory, the Canopy Model. Andy, did you once believe the Canopy Model too?
I toyed with it, but I've come to the conclusion just like you.
But early on, you were in favor of that, maybe. What they did is they said the heavens of day 1 is the space of the universe. If you read my book, Universe by Design, that's what I say on the first page. I think I've changed my mind on that. I don't think the space of the universe existed until day 2. And so the idea is that God created the space of the universe on day 1, and then on day 2 he created the atmosphere. And then that leads you to this Canopy Model, because the water then is identified as being right above the earth, and the earth then, the earth's atmosphere, that would protect you from UV rays and all that kind of stuff. And this is what we call the Canopy Model. And here's a little diagram of what it'll look like. The idea was that it blocked out a lot of harmful radiation, UV radiation and so forth, to let visible stuff through, let you see the stars. And this whole thing was to a very different pre-flood world, which I agree was, but not for this reason. And the canopy collapsed at the time of the flood to provide the windows of heaven, the rains falling down, the fountains of the great deep, a bit something different. And as I said, this model was nice, everybody liked it, and some people still do, but it's largely rejected now by most creation scientists. I think every creation scientist I know rejects it, and it's just not favored much anymore. And if that's the case, then shouldn't we reevaluate the cosmology that was based on? And that's what when I went to work for Answers in Genesis 10 years ago, I had a list of stuff I wanted to do. I never had time to do it when I was at the university. I had like a spare afternoon from time to time, and I'd work on it. A few weeks later, I'd come back, and where was I? It'd take me half the afternoon to figure out where I was and pick up again. The cool thing about working at AIG is I go in each morning, and I could do whatever I want, which is still true. Don't you love a job like that? People ask me, what do you do on a typical day? I go to work and do whatever I want. So anyway, I could sit there all day and just think about this, study on this, read about this, and come back the next day and do it again and do it again. I worked on this for weeks. And it was great. It was liberating. I didn't have anything else to do. At least not at work I didn't. That was fantastic. So I began to reformulate the cosmology, and I'm very pleased with how this has worked out. So a straightforward reading of Genesis 1, as I think the space is the expanse made on day 2. I'm going to say that maybe the atmosphere is included in that. I don't want to totally say the atmosphere didn't exist yet. Here's the problem. Atmosphere and space are modern ideas, aren't they? Can you please tell me where the atmosphere ends and space begins? Some people say the Kármán line, but where's the Kármán line? In the United States, we say it's 50 miles. In Europe, they tend to say it's 100 kilometers, which is 62 miles. And I think I've heard a third standard out there. You see, it's fuzzy. The atmosphere just doesn't, like a switch, disappear, like a ceiling, just land of demarcation. It gradually thins out and kind of melds with what's out there in interplanetary space. So there's no clear distinction between the two, and these are man-made distinctions. And where does God say the two end? I don't know if God really cares. But he's not revealed to us if he does. So how much of the atmosphere is included with this? All of it, some of it, none of it? I don't know. But I'm tending to think more and more that maybe much of the atmosphere is included with this thing that God made on day 2. What about the creation of the heavens on day 1? I asked the question, did God create heavens twice? Well, it could be that heaven and earth is a merism. A merism is where you have two things, extremes, that represent everything in between. In English, we sometimes, if we're looking for something, we may say we looked high and low for something and couldn't find it. Do you have that expression in Norwegian? Does that mean you went to the very top shelf and looked, and you went to the very bottom shelf and you looked, and you didn't look anywhere else? No, it means you checked everywhere in between, too. It's a merism of the extremes of everything, and it includes it all. Ancient Hebrew does not have a word for universe. And so the best thing they have is heaven and earth. When you say heaven and earth, it means everything. And sometimes in English we say, I moved heaven and earth, which means I did everything I could. So we pick that up from Scripture, I think. It's a merism, I think, telling us, in the beginning, God created everything. Now, this is an example of what we call an introductory encapsulation. An opening statement about something and then details to follow. Later on in the book of Genesis, Joseph had one of his dreams, and it starts off by saying, Joseph had another dream, and his brothers hated him even more for it. Well, that's a pregnant pause, a pregnant statement, isn't it? You know, if that's all you had, you'd wonder, well, what did he dream? What was possibly upsetting them and so forth? Well, he goes on to explain the dream in the next couple of verses. It's an introductory encapsulation, details to follow, and I think that's what's going on. The introductory encapsulation here is in verse 1. The actual details of the account pick up in verse 2, and they continue really into verse 3 of chapter 2. Yeah, that's right. The verses and chapters are not inspired. They're men's ideas of where to do it, and they did a bad job on this one. The break should be occurred for chapter 2 should occur at the end of verse 3 of chapter 2, not at the end of verse 31 of chapter 1. Okay, so that's how I handle what those heavens were. It was just simply a statement of creation with more details to follow. Now, this is where it gets to the good part, the science. I've been giving you the biblical stuff so far. I'm about to give you now the sciences I figured out from here, which is getting close to my wrap-up, so in case they start giving me the hook here. All right, I reached 3 startling conclusions about this. I say they're startling because they're anathema to astronomers and cosmologists today. They would say, oh, the universe can't be like that. Well, yes, it can. They just don't want it that way. People start with assumptions. Is the universe infinite or finite? Nobody knows, but cosmologists have their opinions on it. They can't prove it anyway, but they have their opinions if it's finite or infinite. Well, here's startling conclusion number 1. The universe has an edge. For much of my life, I didn't think the universe has an edge. It does now. Now, how does that work? I have no idea. Because you see, at a physical edge of the universe, the physics would break down. Our ability to describe it mathematically would break down. But that's the way they view it. Number 2, I think the universe has a center. If it has an edge, it would have to have a center, I would think. And as a subpoint on that, we're somewhere near the center. I'm not saying we're at the center. I'm saying we're near the center because, after all, what was this thing God made on two? What was this expanse that apparently he expanded off the earth on day two? And if you expand it outward in every direction, you're going to end up with something that's roughly spherical, and whatever you expand it around, i.e. the earth, is going to be somewhere near the center. And again, that's anathema. Most modern cosmologists would say, well, even if the universe had a center, even if it had, the probability of us being anywhere near the center is pretty remote, which is true if you believe in random acts going on here, but I don't. I believe in creation, which is not random at all. And number three, taking this quite seriously, there's water at the edge of the universe. And when I say water, I'm certain it does mean water because, well, I touched on this the other day, maybe didn't catch it. If I say the word water, what do you think of? Liquid H2O. If I say water, do you think ice or snow? No. If you wanted to think ice or snow, I would say ice or snow, wouldn't I? And would you think steam or vapor? No. You would think liquid H2O. It's probably better to say, instead of saying liquid water, we should simply say liquid H2O. Liquid water is kind of redundant, isn't it? Well, Hebrew works the same way. The Hebrew word for water is mayim. And it always refers to liquid H2O. There are Hebrew words for ice and snow. They appear in the Old Testament. And there are Hebrew words for steam or vapor. They appear in the Old Testament. If God wanted to tell you it was some other form of H2O, he could have used that term, but he didn't. He said water. So I'm inclined to believe it's liquid. People may say, well, wait a minute. Well, given the conditions in outer space, low pressure, low temperature, how could it possibly be liquid? Well, again, this is the physics at the edge of the universe. Write me some equations that would describe the physics at the edge of the universe, and maybe we'll have an answer here. It's beyond my ability. I know Andy can't do it either. I don't think anybody can. Now, this is where the science gets very interesting. I was writing this paper. I was researching it. I took weeks. I was writing. I'd go in and I'd write all day, and I'd edit it, and I'd come in the next morning, work on it again. And I remember, I wish I would have written the date down. It was 9 years ago sometime. I go into the office one morning. I'm in the office for about half an hour or so, maybe half an hour probably. And suddenly I'm sitting there writing, and it just dropped out of the sky on top of my head. And I said, wait a minute. Wait a minute. Wait a minute. Water is made of baryonic matter. Probably only one person here knows what that means. It's made out of protons, neutrons, and electrons, okay? Normal matter, okay? And there's a principle in physics called the Third Law of Thermodynamics, which I think it demands that this water have some temperature, non-zero temperature. Didn't know there's a third law, did you? There is. Never hear about that one. So, if it has temperature, and I think it does, then it must radiate. Baryonic matter has to radiate. So if I'm sitting here near the center of the universe, then I would expect that there would be I'm surrounded by this distant shell of water that's radiating, so I would expect there'd be a radiation field coming from all directions in space. Now, I don't know what the initial temperature of it would be, but you know what? I know the Hubble relation holds, which tells us that with great distance, light is redshifted towards cooler and cooler temperatures. And since this is beyond everything in the universe, it's going to be the coolest. So this is going to be a pretty low temperature radiation field. You mean like the CMB? You know, I wasn't trying to solve the question that had been posed to me many, many times when I was trashing the Big Bang. If it doesn't come from the Big Bang, what is it? I was working on a cosmology. That's all I was trying to do. And that suddenly one morning it just hit me. Oh, I have an explanation for that now. In fact, if this is correct, the physics will not allow you to not have this. It has to be there. And I kept thinking, if somebody would have taken this seriously and gone through that like I did 9 years ago now, and applied the physics as I've done now, they could have predicted this radiation field a long time ago, before the evolutionists did in 1948. I'm off the hook because I wasn't alive in 1948. And when they discovered the background radiation, I was in 5th grade. So it was way before my time. So I'm not at fault. And the people who should be at fault are probably long since deceased. But somebody who took Scripture very seriously could have made this prediction a long time ago, but nobody did. But that's my cosmology. I think it's coming from Scripture. I know that it's very different from the Canopy Model, and I had some comments yesterday. Instead of giving yesterday I was telling you what was wrong with the Canopy. Today I was telling you my alternative, which I think makes more sense, explaining what the day 2 thing was. And as an added bonus, you get an explanation for that CMB. And so I'm trying to use this as a foundation to finally start building a creation model of astronomy and cosmology. We don't have one. The geologists have several they can choose from, flood geologists, biologists have baraminology and things like this. We astronomers, we're way behind everybody else. It's about time we catch up. And I covered your prayers on that. We have some guidance. I have a few other astronomers working on it. We'll be meeting again this summer for a day of discussions. Andy, you're welcome to join us if you want to come a day early to the meeting. Yeah, so come on that Thursday unless you want to go to one of the other meetings. And anyway, again, I want to appreciate you for being great hosts and hostesses for me. I've had a fantastic time, and I look forward to coming back and being with you again. But thank you very much.
Thank you, Andy. Thank you so much.